Hello everyone. Today we'll be naming organic compounds, aliphatic organic compound to be precise. So we have a compound here that I want to name. So you can go ahead and name the compound. But before we go on naming the compound, if you are very new to naming organic compound, I'm going to do a revision for us. So how do we name organic compound? And what is the steps that we'll take? So I'm going to show you the steps I want to take. So first of all, let us start. So let us start with the names of organic compounds. So there are different names of organic compounds. Actually, three: the common name, derived name, and the IUPAC name. IUPAC name is a name given by the International Union of Pure and Applied Chemistry. So this system works in a simple way. It works in a system of suffix, prefix attached to a root and attached to a suffix. So this is the way it works. So what is the root? Root is simply the parent hydrocarbon. Suffix is the principal functional group. In a case where there are multiple functional group, we prioritize. We take the functional group that is attached to the longest possible chain, and the prefix is simply other substituents. So look at what I mean. For example, for a compound CH3 to CH2 to CH, um, yes, CH2 and OH with a methyl. If a methyl is attached to this place, then I'm going to remove this, go to having a single hydrogen. You understand? So let's go. This is a methyl, sorry. So if we want to name this, first of all, I'm going to identify the root, which is the first one. So the root is the longest possible hydrocarbon. So this is going to be the root here. This is going to be the root because this is the longest possible one we can have. So after identifying the root, so what do we call this root? There's a name that are given to them. So after identifying the root, which is the longest possible chain, longest possible continuous chain, next thing for us to do is to identify the suffix. So I've identified the root, so I'm going to add the suffix. So the suffix are the functional group that are attached to the roots. So in this case, we can see that we have two suffix here, or two functional group, which is the methyl. This is the methyl and methyl and anhydroxy, which is an alcohol, hydroxy. So in this case, which one do we pick as the suffix? Because we can have only one suffix. We can have multiple prefix, but we can have just one suffix. So in this case, what do we pick as the suffix? I want to pick the hydroxy, which is the OH, as the suffix. Why? Because it is the one attached directly to the longest possible chain. So we have successfully gotten our root and our suffix. So we're going to add it together now. So since it is a theory carbon atom, it's going to be a prop. A prop. If this was a two, it's going to be an eight. Get me? If it's one atom, carbon atom, it's going to be a met. Four is going to be a boot. But in this case, it's just theory, so it's going to be prop. So we have prop. What? The one that's the suffix that is directly attached to the longest possible chain is what? Anhydroxy, which has the suffix of anol. So it's now what? It's prop anol. But we're not done because we have another substitute attached to it. So we don't just write the name of the substituent like that. as like methyl propanol. What we're going to do is we're going to check the position where the substance has attached to the longest possible chain. And if we count from this side, one, two, sorry, count from here, one carbon atom, two carbon atom, and three carbon atom. We're going to find out that it's attached to what? The second carbon atom is going to make it two methyl propanol. So this is just a revision on how to name organic compounds. So let's go to the main problem. So this is the problem we have covered. So the first step we take is what? Is by identifying the longest continuous carbon chain. After identifying that, we're going to name it according to the number of carbon atom it contains. Then we're going to add the appropriate suffix to indicate the principal substituent. Okay, so now let's take the first step. So this is one, so this is the longest possible carbon chain, first of all. So after identifying this, we're going to name it, we're going to number it to get the smallest number for the principal substituent, which is going to be, let's name it in both ways: one, two, three, four. And if we name from this side, it will be one, two, three, four. So first of all, what are the substituents? If you can look, you find out that we have a double bond here. This is a double bond, and it's also a double bond. So this is not going to be an alkene, it's going to be an alkyne. So the an alkene. The alkene is going to be the substituent. So we have what? We have, if you check here, first of all, we have 4 and 1. So 4 and 1. Two two double bond, like two double bond, which is going to be a diene, diene. Or we have one. If you count from this side, we have 1 and 3. It would be 1, comma 3, diene. So between 1 and 4 and 1 and 3, which one is the smallest? Actually 1 and 3, because if you add 1 to 3, it's going to give us 4, but if you add 4 to 1, it's going to give us 5. So I'm going to pick this one as the what? Substituent. Get me? So this is going to be the principal substituent, or the suffix. So counting it again, 1, 2, 3, 4 is 4. So it's going to be boot. The root addition, so 1, 3, 1, 3, diene. Diene. Then we have gotten the root and the suffix, but it's many words. So we have identified the root and the suffix. We have to now identify the prefix. So if we check, we're going to find that there's a chlorine atom attached to. We took the smallest number for the suffix, which is 1, 3. So this is going to be 2. It's going to be attached to the second carbon atom. We're going to make it 2 chloro. So the answer is going to be 2 chloro boost 1, 3 diene, which is 2 chloro boost 1, 3 diene, option C.